Today we're going to be talking about ratios, proportions, and using similar polygons. We will be able to use ratios and proportions to write and solve equations, and we will be able to identify similar polygons and use them to find missing side lengths and angle measures. So, if our goal is to find the ratio of the width to the length of the following rectangle, the first thing we would not need to know is what a ratio is. A ratio is an expression relating to quantities. So therefore, the ratio of the rectangle, if we wanted to relate width to length, would be 8 inches over 2 feet, which would simplify to 4 inches over 1 foot. However, in ratios, we want the units to typically be at the same, so we're going to convert our feet to inches so that both parts of our ratio are in inches. So that would be 4 inches over 12 inches, which would then simplify to 1 inch for every 3 inches. Typically, we see ratios written as fractions. They also might be written as 1 inch colon 3 inches. So, in previous units, we've talked about congruent polygons, and we know congruent polygons have the same size and the same shape. Similar polygons have the same shape, but they're different sizes. So both of them have the same shape, which tells us that the angles are congruent. In the congruent polygons, they are the same size, which tells us that the sides are congruent. In similar polygons, since they're different sizes, the sides won't be the same. The sides are proportional. A proportion is two ratios, is an equation relating two ratios. So, our next goal. Are the following triangles similar? If so, state the scale factor and write a similarity statement. In order to solve for similarity, we use a statement of proportionality, which is a proportion. In order to figure out that proportion, we're going to pair up. Let's start with the shortest side. So the shortest side here is AC, because it's only 4. AC over, what's the shortest side in our small triangle? DF. That ratio would have to equal our mid-sized side is AB over our medium size here would be DE. Would have to be the same ratio as our biggest sides. So BC over EF. So let's plug in the side lengths and see if they come out to be the same fraction. AF is 4 over DF, which is 2. AB is 6 over DE, which is 3. And BC is 8 over EF, which is 4. Now initially, they don't look like they're all the same. However, all of these simplify to 2 over 1. Therefore, our scale factor is 2 to 1. Scale factor is the ratio of corresponding sides Since the proportions are true, we know the triangles are similar. The similarity statement would be, we're going to use our first triangle, and I'm just going to go in alphabetical order, A, B, C. And our symbol for similarity is just the one squiggle like we had in congruent, but without the equal sign. Now let's see, we need to make sure that our letters for our second triangle are in the corresponding order to where the letters are in our first triangle. So AB, side AB went with side DE, so we're going to start with DE. And then I know side BC went with side EF, so it has to go EF. Or if you're looking at the triangles, we did the medium side and then the large side. So here we would have to do the medium side and then the large side. We can describe the factor of change using the term dilation, which just means the stretching or shrinking to change the size. Now, let's try to use the properties of proportions to simplify and then solve the following proportion. So if we wanted to solve this proportion, we need to know the cross product property. And what that says is if we have A over B equal to C over D, cross product means cross multiply. So we're going to multiply A times D, and that will equal B times C. And then we can solve that. So in this proportion here, A times D would be Y times 5, which will give us 5Y. And then B times C would be 50 times 3, which is 150. And then to solve that, we'll divide both sides by 5, and we get that Y equals 30. So let's use the same property here. The thing that we're going to have to remember is when we multiply the 300 with Y plus 2, we have to multiply the whole thing. So it's going to be 300 times Y plus 2 equals 500 times Y would just be 500 y. So here we'll need to distribute. Then we need to get all the y's on one side, so I'm going to subtract 300y. Leaves me at 600 equals 200y. Divide both sides by 200. And I get that y equals 3. Next, we're going to use the property of ratios and similarity to solve the following proportions. So, in this first example on the left, BC to AB has the ratio 1 to 2. So BC over AB has a ratio of 1 to 2. So from this figure, I'm going to plug in what I know about BC and AB. BC is 4 over AB, which is x plus 4, equals 1/2. Now I'm going to use my cross product property. I get that 8 equals x plus 4. Subtract the 4, and I get that x equals 4. Now, the question wasn't asking us just to solve for x, it asked us to find AC. We know that AC equals 2x, so we'll equal 2 times 4, which is 8. Next, if ABC is similar to triangle EDC, find DC. So, the two sides that we know AC and EC, and we know that AC and EC are proportional. So AC over EC. That proportion, or that ratio, if I need to find DC, which is from the same triangle as EC, so I'm going to put it on the bottom, based on up here, DC has to be proportional to BC, which is right here. Now, we don't know what that is, but we do know that the whole distance from B to D is worth 10. So if this part is worth x, we know that this is left, whatever's left over. So it's going to be 10 minus x. So let's fill in what we know. AC is 8. EC is 4. BC is 10 minus x. And DC is x. So once I cross multiply, I'll have 8x equals, don't forget to distribute, 40 minus 4x. Add my x to the other side to get them all on one side. 12x equals 40. Divide both sides by 12. And x, 40 over 12 would simplify to 10 over 3. So next, given the similarity statement that ABCD is similar to WXYZ, write a statement of proportionality. So we want to know all the parts that are proportional. So I'm going to start with AB because those are the first two letters over WX has to equal, next two are BC over XY equals CD over YZ, which would have to equal AD over WZ. So next, if we want to find the scale factor, we have to reduce any of these fractions that we know both numbers for. We don't know AB, BC, or CD, so I'm going to use the one with AD and WZ because I know AD and I know WZ. So AD is 14 over WZ is 10, and if we simplify that fraction, we get 7 over 5. So that's our scale factor. So next, we're going to find the values of all the missing side lengths. So we need to find AB, BC, and CD. We know AB goes over WX, and we know WX is 8, and that has to simplify to 7 over 5. So 5 times AB has to equal 56. And if we divide both sides by 5, we get that AB equals 11.2. For BC, we know BC goes over XY. XY is 4, equals to our scale factor of 7 over 5. So 5 times BC has to equal 28. If we divide both sides by 5, BC equals 5.6. And finally, CD goes over YZ. YZ is 3. Set that equal to our scale factor. 5 times CD equals 21. Divide both sides by 5. And we get that CD equals 4.2. So let's determine the perimeter of each figure. For A, B, C, D, we're going to add up all the side lengths. So we have the 3 that we just calculated. Plus the one we were given. And that gives us a total of 35. Then for WX, YZ, we'll add up the 4 that we were given. So 8 plus 4 plus 3 plus 10. That gives us 25. So if we take the ratio of the perimeters, we would have 35 over 25, which if you simplify, still comes out to 7 over 5. So the ratio of the perimeters is the same as the scale factor. For our final example, are these polygons similar? If so, we're going to explain why they're similar, write a similarity statement, and determine the scale factor. So, if these two angles are congruent and these two angles are congruent, we know from previous units that the third angle also has to be congruent. So, are the angles congruent? Yes. So that's step one. The next thing we need to know, are the sides proportional? So let's match up the sides. We need to do the longest side with the longest side. So the longest side in this triangle is 12 over the longest side here is 9, and that simplifies to 4/3. So let's look at the medium sized. Here we have 8 over 6. That also simplifies to 4/3. Our shortest sides would be 6 over 4.5, which also simplifies to 4/3. So since all three are the same, all the sides are proportional. So yes, they are similar. So let's write a similarity statement. Triangle, I'm going to just go in alphabetical order, LMN, similar to L to M, went from the angle with 2 marks to the angle with 1. So from 2 marks to 1 mark would be T to P. And then that leaves O. And then finally determine the scale factor. Well, we already did that when we were checking the ratios. So the scale factor is 4 to 3. I forgot my triangle symbol up here. And finally, for your summary, Compare and contrast congruent figures and similar figures. Also, where do you see similar figures outside the classroom? That's all for today. See you